I'm Catherine Thomas. I work for the Friends program, and we're so happy you're all here. Especially, we are welcoming so many members, which usually is not the case for Friends Talks. So, particular welcome to you. Jizin will be introducing Cecilia. I ask only that you turn off your phones so that we're not disturbed by ringing. And this is Jizin Dai, one of our friends of the Institute.
Good afternoon and welcome to today's Friends Talk with the member at IIS. My name is Jixin Dai and I am the member of the IIS Friends Group. Cecilia Payne-Gaposchkin was one of the most distinguished astronomers of the 20th century and the first person to earn the PhD in astronomy from Harvard. In her groundbreaking 1925 doctoral thesis, Stellar Atmospheres, regarding one of the most brilliant PhD theses ever written in astronomy. She applied spectroscopy and the emergent principle of quantum theory to demonstrate, contrary to prevailing scientific opinion, that hydrogen and helium are the most abundant elements in the universe. Her work fundamentally transformed astrophysics and laid a foundation for our modern understanding of stellar evolution and cosmology. Yet, the significance of her discovery was not immediately recognized and was even criticized. Under pressure, she was compelled to include a cautionary sentence in her thesis, which I quote here: "The enormous abundance derived for these elements in the stellar atmosphere is almost certainly not real," which undercut her own correct conclusion. 4 years later, the same senior astronomer who had questioned her findings independently re-derived stellar abundance using a different method and confirmed Payne's result, ultimately vindicating her original insights. Her story reminds us the transformative ideas are not always embraced at first, but intellectual courage, disciplined reasoning, and the fidelity to evidence endure. Throughout her professional and personal life, Payne-Gaposchkin defied expectation and broke barriers. She became the first woman at Harvard to receive tenure, and later the first woman to chair the department there. Even so, it is widely recognized that both the university and the broader scientific community were slow to fully recognize the contribution, the magnitude of her contribution. Today, we have the special opportunity to hear about the life and the legacy from a unique personal perspective. Her granddaughter, Professor Cecilia Gaposchkin, the Willis Doney Member of the School of Historic Studies here at IIS, will reflect on her namesake remarkable achievement through the lens of the family memory and the personal legacy. Professor Gaposchkin is the Charles Alfred Collis Professor of History at Dartmouth College, where she has taught since 2000. She earned her PhD from UC Berkeley in 2001 and specialized in religious and cultural history of high and late medieval Europe, with particular expertise in Capetian France and Crusades. While at IIS, she's working on a book about history of relic cults in Paris, originally titled The Sacred Paris, Relic Cults and Political Imagination in Medieval Paris. Professor Gaposchkin has received numerous honors and fellowships throughout her distinguished career, including a recent Clare Hall Fellowship at the University of Cambridge and the Guggenheim Fellowship from the Guggenheim Foundation. It is a special privilege to welcome a scholar who carries an extraordinary intellectual legacy and a remarkable scholarly voice of her own. Please join me in warm welcoming Professor Gaposchkin.
Thank you, Jixing, and thanks for everybody for coming. I'm really glad that I can offer something here of interest to, that's not my own research, but that is of interest to everybody here. And I am really grateful that you have come. So as you've just heard, I am a medieval historian, a professor at Dartmouth College. I'm here. I'm honored to be here for the year. I'm working on a book called Sacral Paris about relic cults. But more pertinently, I am, let's see if I can get this to work, the granddaughter of this woman, Cecilia Payne-Gaposchkin, through my father. Let me begin by saying that what I offer here comes from a standing talk that I've given in a variety of different venues, to her alma mater in Cambridge, in London, to the graduate students in astronomy at Rutgers, and a number of other occasions. It comes out of the perspective of family memory and maybe something like the perspective of a historian. I'm not a scientist. The science itself is quite beyond me. So what I offer is something of an understanding less of the science than of the remarkable life that this woman, that my grandmother had, and maybe a bit of a novice's explanation about the science of this woman who quite literally broke all the expectations of her time, both as a woman and as a scientist. Now, Payne-Gaposchkin is primarily remembered as one of the most important astronomers of the 20th century. Not one of the most important women astronomers, but just simply as one of the single most important and decisively influential astronomers of her time. The first line in her Wikipedia entry reads, Cecilia Helena Payne-Gaposchkin was a British-born American astronomer and astrophysicist who proposed in her 1925 doctoral thesis that stars were composed primarily of hydrogen and helium. This is to say that in her PhD work, which she completed by the time she was merely 25, puts me to shame, Payne-Gaposchkin, Payne at the time, established that the central chemical element of hydrogen was the most common element in the universe, which means that for all intents and purposes, in her doctoral research, she quite literally discovered the composition of the universe. Before that time, it was the conventional wisdom was that the chemical makeup of the universe was reflected the elements of the Earth's core, very different profile of the Earth's crust, very, very different profile. As you heard, she was also the first woman to be tenured through the ranks and the first woman to be made full professor at Harvard. She is increasingly revered for her pioneering role as a woman in science. And I have heard it said multiple times that had she been a man, she would have won a Nobel Prize. Now, if you do a Google search on her, you get images like this, this, this. She's been monetized. You can get T-shirts, inspirational stickers, refrigerator magnets. Those are the refrigerator magnets. There's some mugs. You can get your kids a Cecilia Payne puzzle for Christmas. She's made it, this is my favorite. She's made it onto a pack of playing cards next to Hillary Clinton and Susan B. Anthony and Gertrude Stein. I just learned from a colleague in England a few weeks ago that the English Heritage Trust is adding her to their Blue Plaques scheme. This is the scheme in London that tries to identify those important markers about people in London history. On April 22nd, they're having a ceremony to unveil the blue plaque at 70 Lansdowne Road in London, which is where she lived in the years she went to university. I'm sad I won't be able to go to they have a big ceremony planned. So let me begin by saying that she died in 1979 when I was 9 years old. Here is a picture of the two of us about 5 or 6 years before that. I must be about 4 there, I think. I do have some memories of her quite clearly. They were of a musty house, of her sitting on a sunken couch. In fact, that sunken couch doing needlework. Let me show you a picture of her needlework. This is one of her examples. It looks like an abstract art. It was actually her needlework rendition of the Cassiopeia supernova that she had been studying at the time. I remember papers strewn all over the desk of Sunday dinner. I remember her playing violin in bed, right? We, her grandchildren, called her Mide or Mideka, which derived from the Scottish term for mother, and which is what she suggested that my own mother, her future daughter-in-law, call her when they first met. And that's what we refer to her when we talk about Mide. So my memories are of a grandmother and not of the remarkable woman whom I only got to know later as an academic and intellectual and something of a role model, mostly by reading her own memoirs and in discussions with my own family, particularly my father. And my task today is just to introduce you to her. So Cecilia Helena Payne was born here on May 10th, 1900. The house was recently on the market and they advertised it by a reference to her, that being her birthplace. 1900, Queen Victoria was on the throne. This is how people dressed. This is how they got around. She was one of 3 children, 2 girls and a boy. It was a moderately well-off, but not an affluent family. Her father was a lawyer and, to my delight, an Oxford historian of the Americas. But he died when she was just 4 years old, and after that, the family finances became tight, strained. Cecilia would always resent her feeling that the resources of the household went in support of her brother Humphrey, whose education was considered to be preeminent. And in fact, this is important to me, he became an important classical archaeologist and head of the British School at Athens, which I care about because my husband is an ancient historian who spends a lot of time at the British School. So that's another nice little tie. In any event, in 1904, 1906, money was tight, but education was very important in the household. And she was clearly precocious, immensely talented academically, and also musically. By the age of 10 or so, she knew French and German fluently. Her mother was of German extraction, and so they probably spoke it in the household. But she would use these throughout her life. She had also mastered the basics of Greek and Latin. Her violin playing was so good that in high school, the famous composer and conductor who happened to teach at her school, Gustav Holst, does anybody know that name? Yeah, okay. So encouraged her to become a musician and a conductor. For those of you who don't know who Gustav Holst is, his most famous piece, orchestral suite, is called The Planets, which I also quite like. In her autobiography, Cecilia discussed the extremely careful education that she received at her primary school in Wendover, which was a program of study that prioritized memory and memorialization, in addition to a kind of obsessive dedication to acute observation, which were practiced and drilled incessantly in grade school. At a later age, she could recite every word of poetry that she had learned by heart by the age of 10. Now, modern teachers, I think, would be quite horrified at this curriculum, this method of teaching, but she talks about it, her early education, with enormous gratitude. She wrote, a very good memory has always been one of my assets, and I believe that I owe it entirely to this early training. In these memories, with a kind of almost painful nostalgia, she looks back to her discovery of science as a child, which began, she recalled, with the discovery and of a love of nature when she was, as a young child, walking through the woods. Quite early in life, she determined to become a botanist. And this is one of my favorite details that she recalls. She said she was worried that she needed to grow up fast lest everything be discovered by the time she got old enough to participate. What was clear, however, was that no one much thought that she should become a scientist, that it wasn't practical or appropriate for a girl. Instruction at her school, girls' school, sacrificed science to the study of religion, a trade-off she decidedly did not appreciate and in retrospect quite disdained. I want here to read you one exchange she remembered from this period. The sense of living in a man's world continued to oppress me, she remembers. Why, I asked Miss Edwards. This was a beloved early teacher. Why, I asked Miss Edwards, was Jesus a man and not a woman? Because in his day, she replied, a woman could not have done the things he had to do. But I did not find this convincing. So actually, frankly, I'm pretty impressed with Miss Edwards' sort of quick-witted reply. I think that was done pretty well. But Anyway, Cecilia's desire to pursue what was clearly understood to be a man's path was not encouraged. At the age of 12, as she left one school for another, the headmistress told her that she was, quote, prostituting her gifts to wish to go into science. So instead, she became an autodidact. She found old copies of scientific treatises and copied them out by hand. At 14 or 15, she laboriously read through a German version of Newton's Principia and transcribed a translation out by hand. At home, driven by her desire to become a botanical scientist, she began to collect plants. And then, following the suggestion of one supportive teacher, she began to draw them. This was part of her training in her observation. And here, do you see that? Yeah, here I show you a drawing that she did later in life, clearly a study. And you can see she had great skill, great precision in her observation. She will later credit this deep care, this deep attention to observation, into truly looking to see, to understand, rather than just to gaze, as the foundation of her own scientific process, which later, of course, led her to be able to observe, to really see the data that she was getting from the stars. But at age 15, she often had contempt for her students. So when she was writing her memoirs, she came across in her notes a condemnatory verse that she one day wrote about one of her instructors at this point, which reads, "Oh, out on you, fond instructor, perverter of nature's laws, explaining cause by effect, confounding effect with cause. I could say 1,000 things about you, but I will desist, for you are a charming woman, but you are not a scientist." So this is the situation until a fellowship at age 17 allowed her to matriculate at St. Paul's School for Girls, a prestigious private school in central London. This was a complete game changer for her. As a school, it had laboratories, it had actual science teachers, and she was finally given the support and the encouragement and resources that she was craving and that fed her passions. After a year at St. Paul's, she applied to Newnham College at Cambridge. This is an all-women's college at Cambridge University. There I am with my mother and my father. That's her son, her eldest child. We visited a few years ago. So Cecilia matriculated in 1919, and you'll imagine this is right after the end of the First World War. What she remembers as she continues to brim, 60 years later, writing her memoir, you can feel the excitement seeping out of her as she recalled the optimism and the energy that pervaded her experience and the campus in general. She went with the intention of studying biology and botany, but contact with the great British physicist and mathematician Sir Arthur Eddington shifted her interests to physics and astronomy. She remembers a now famous public lecture that Eddington gave at Cambridge in 1919 on his famous Brazilian expedition to observe a total solar eclipse in order, and this must be said because we're at the IAS, to test Einstein's theory of general relativity. And she remembers this lecture as her conversion moment to astronomy. To the end of her days, she considered Eddington to be the greatest intellect she had ever known. Now, none of this was seamless. Newnham had to set up separate lab spaces for women who weren't allowed into the men's lab, of course, for fear of distracting them. She learned, however, about a small observatory that had been donated to Newnham and went out and began there to look at the stars. And this I got out of the Newnham archives a couple of years ago, an old photograph of that observatory. I went a few years ago to see it. There it is, still on the Newnham grounds. There I am with the telescope that she was using, and through which she first was able to look into the deep black of the sky and begin to observe, really to truly see those sparkling little diamonds we call stars. Now, it was something still of an uphill battle to be a woman studying the sciences in 1919. She was permitted to study, but she remembers being the only woman in one advanced physics course where she was made to sit in the front row alone, and where the eminent Ernest Rutherford would sardonically begin each of his lecture with the opening phrase, "Lady and gentlemen." The experience was so humiliating for her that for the rest of her life, she always hid in the back row of any lecture hall. And when she spoke of her desire to become an astronomer to the director of the Solar Physics Observatory at Cambridge, this is a man called Frederick John Marion Stratton, he told her, quote, "You can never hope to be anything but an amateur." Okay, none of this is particularly encouraging. It was, in fact, Eddington himself who had given her the encouragement that she needed. In her first accidental, as she remembers it, face-to-face one-on-one meeting with Eddington, she remembered, "The moment had come and I wasted no time. I blurted out that I should like to be an astronomer." Was it then or later that he made the reply that was to sustain me through many rebuffs? "I can see no insuperable objection to that," he replied. I have to remember this as a teacher, about how often really encouragement from people can be enough to get a student through. I find this quite touching. Anyhow, Cecilia could study physics and chemistry at Cambridge, but she could not actually earn a degree in it. Cambridge didn't award degrees to women until 1948. Can you believe that? Okay. That, in a sense, was a technicality of sorts because she was part of the program, but there was absolutely no question of her doing graduate study at Cambridge. Women were simply not permitted to participate in graduate study. And so for that, she would have to go to America. And so she went, initially for just 1 year, to take up a research fellowship that had been organized by Harlow Shapley, the director of the Harvard College Observatory, and she ended up staying a lifetime. Now, the Harvard Observatory that she arrived at was, in fact, filled with women. The observatory employed women as their computers to compute. This is obviously before the invention of the computer. And this image shows Pickering there in the back. The director is he died in 1919 when Shapley took over. But so the image shows Pickering with his computers in 1913. Now, a number of these women are remembered as extremely competent, talented astronomers in their own right. Among them were women like Annie Jump Cannon and Henrietta Leavitt, who both had important scientific careers of their own. These women were capable, they were competent, and they were cheap. Pickering would measure the cost of his projects in terms of the girl hours that were needed to complete them. This is the same group a few years later, and Cecilia is here in the background. I like the fact that she's like taking the place that Pickering had in the former picture, still in front of the same doorway. Right. So this was Harvard in the 1920s. And it is here that she began to exploit certain developing methods in spectroscopy to analyze and interpret the photographic evidence that was collected about the stars. In 1922 or so, the photographic evidence of stars would look like this. When photographed in a spectrum, they looked like this. To work with this kind of data, the ability to see, to observe, was utterly crucial. Of course, there were no computer algorithms to help. Women, we saw, were the computers. So after a year's fellowship was up, Cecilia basically just stayed on in the position that she had. There was no formal PhD program in astronomy at Harvard yet, but Harlow Shapley was an ambitious young director. He took over for Pickering in 1919, and he basically used Cecilia as a mechanism to establish the Department of Astronomy at Harvard. She matriculated as a graduate student and simply just continued on with the work she was doing. And when she had completed what she had been working on, she simply wrote it up in the form of a book called Stellar Atmospheres, which was then published as the Harvard Monograph #1. And for this, she was granted a PhD. It was the first PhD that the Harvard granted in astronomy, and the year was 1925. So let us talk about this PhD. It is considered still the most important PhD ever written in the field of astronomy. And since I'm completely out of my element, I'm going to outsource this to YouTube.
There was a time not long ago when everyone thought that the planets and the stars were all made of the same stuff as Earth, the same elements and compounds, all in the same proportions. This was also a time when we thought we had invented the best possible tools to observe stars and planets in close detail. But it turned out we were wrong. It wasn't until 1925 that a young astronomy student found the key to observing what was really out there, and she changed the way we look at the universe in more ways than one. Cecilia Payne was born in England in 1900, not a time when women were welcome in the world of science. But she was smart and passionate and pursued her true love, astronomy. In 1923, Payne emigrated to the US to study at Radcliffe College, now Harvard College Observatory, one of the only academic institutions at the time that accepted female students in the discipline of physics. And in just 2 years, she became the first person to earn a PhD at the college with what's been called the most brilliant thesis ever written in astronomy. In it, 23-year-old Payne laid the groundwork for basically everything we know about the stars. And for the first time, she corrected our assumption that the whole universe shares Earth's elemental makeup. Before Payne, everyone assumed that the stars were made of basically the same 100 or so elements found on Earth. It stood to reason at the time that the stuff we know here must be the same as the stuff out there. But once we started to use spectrographs, tools that allow us to read the elements in the stars, the universe started to look confusing. Spectrography was first developed in the late 19th century when scientists realized that if they passed light through a medium like a gas and broke it into a spectrum, certain wavelengths of color would be missing from that spectrum. After doing this enough, they were able to tell which elements absorbed which wavelengths, and the science of spectrography was born. This was clearly useful for observing the elements in the atmospheres of stars, a medium that lay between us and the constant source of starlight. And it appeared that the stars tended to have all the same elements as Earth in more or less the same proportions. But soon, a weird pattern emerged. The spectra from all known stars consistently formed 7 different absorption sequences. This seemed to suggest that there were 7 kinds of stars, each composed of the same 100-odd elements as Earth, but with some slight variations. But why would there only be 7 different types of stars when there are more than 1 million possible combinations of those 100 or so elements? It just didn't add up, and no one had a good explanation. But Payne suspected that we were looking at the problem in the wrong way. She hypothesized the 7 spectrum patterns we were seeing weren't the result of different combinations of elements, but they were created by 7 different temperature ranges. How could that be? Well, in matter, atoms are normally swarming around each other and colliding. The higher the temperature is, the more atoms move around and the more collisions there are. And in really exceedingly high temperatures, sometimes atoms can collide so fast that one of their electrons will essentially break off, creating an ion of that atom. So for example, if an atom of helium, which typically has 2 electrons, is in one of these high temperature mosh pits and it loses one of its electrons, it'll turn into a helium ion. So now, because they have new, slightly different chemical signatures, these ions absorb different wavelengths of light than their parent elements do. Payne hypothesized that since hotter temperatures mean more ionization, that could explain the different absorption patterns that astronomers were finding. But then the question was, ions of what? She went about determining which ions could create those mysterious absorption patterns and at what temperature range they could each exist. That could have taken forever because Payne was dealing with not just that original 100-odd elements, but also countless variations of each. But as soon as she began studying ions of hydrogen, everything fell into place. The 7 different spectrograph patterns created by starlight perfectly corresponded to those made by 7 groups of hydrogen ions, each of which could only exist in its own temperature range. After identifying those groups, Payne was able to study other ions that could also exist at those temperatures and determine which ones could make the spectral patterns that everyone was seeing. The thing was, most of what could be found in those lines were ions of helium, but not much else. For the first time, it was clear that the stars were not made of the same elements as Earth, but overwhelmingly of just the 2 lightest elements, hydrogen and helium. Hydrogen, Payne realized, was about 1 million times more abundant than any other element in the stars. And from this new understanding, scientists were able to form all sorts of new theories that address some of the biggest issues in the cosmos. Like that the universe was originally made of hydrogen, and then the stars created heavier atoms by fusing hydrogen atoms together and the heavier elements that followed. Payne's research made it possible to read the histories of stars by knowing not only their chemical makeup, but their temperatures and densities too. Still, it was 1925, and Cecilia Payne was a woman. Her advisor urged her not to publish her findings in her thesis because they were too controversial. One professor said they were clearly impossible. Regrettably, she took their advice. But then a few years later, her advisor published the same results that Payne first discovered and presented to him, and is still sometimes credited with her work to this day. That's why we're doing.
Did anybody follow that? Because that's beyond me. I think she's adorable, but she's actually wrong. Henry Norris Russell, who was at Princeton, was not her advisor, but was deeply involved. Shapley at Harvard was her advisor. But she's not wrong that her advisor, Shapley, along with Russell, discouraged her from publishing her results. Now, the issue is in part that the findings that the sun, stars, and the universe were mostly hydrogen went so firmly against long-held conventional wisdom that her advisors and seniors were skeptical of the results she had, and she was discouraged from publishing them. We, hearing this story, are furious at them, as I think was she. But in fairness, this is a point that astronomer who invited me to give this talk a couple months ago, version of this talk to his graduate students, and who works in this field, made to me, that they may have just been being quite cautious, because in her interpreting her findings, Cecilia was leaning into a series of really cutting edge research in quantum physics and other things I don't understand, but that those methods hadn't yet been tested or approved, and so they weren't yet sort of firmly part of the apparatus. So she was doing things, and she was reading all the current stuff to help her come to her conclusions, but there was some maybe skepticism that all was an appropriate working method. So maybe their caution was not entirely inadvisable, but it certainly rankled her. And in her memoir, she takes herself to task for not sticking to her guns. There
was a time not long ago when everyone thought.
Okay, so that's Russell, that's Shapley. And she writes, I was to blame for not having pressed my point. I had given in to authority when I believed I was right. This is another example of how not to do research. I note it here as a warning to the young. If you are sure of your facts, you should defend your position. And as you learned, or as we've been told, within a decade, she had been proven quite correct by none other than Russell himself, who came to the same conclusion through some other methods. But the fact that Russell thereafter was credited with the findings felt very, very unfair. And it's really only in the last few decades that she's been more and more credited. You know, the history of science books are being reworked to focus on her contribution. I want to stop here and show you this picture just to furnish an example of the texture of work and life at Harvard College Observatory in the 20s. Brilliance does not need to be monastic. So this is 1929, when a group of the people at the Smithsonian staged HMS Pinafore, the Gilbert and Sullivan. And here we have Cecilia playing the lead role right there. Cecilia then simply stayed on at the Harvard Observatory in a permanent but a technical capacity to continue with the work she was doing. She acquired U.S. citizenship in 1931, and about this time, for the first time, she fell in love, and it went badly, and her heart was broken. And I have tried to figure out who she fell in love with. There's no one, nothing in the records, nothing in her notes. My father didn't know. So that's a mystery. But to manage her subsequent despondency, she decided to go on a research trip to Europe, organized around the 1933 Astronomical Society meetings. Now, although she did not have a formal faculty position at Harvard, she did have a reputation as a fine astronomer. At one point, Edward Hubble, at the time director of the Mount Wilson Observatory in California, jokingly called her the best man at Harvard. Now, this was obviously a compliment to her. It was probably more a dig at Shapley, with whom he had an ongoing rivalry. In any event, there were astronomer colleagues the world over who knew her work, and she organized to go and visit some of the more important observatories and look at different telescopes and talk with leading astronomers in Northern Europe, particularly in The Hague, in Denmark, and Sweden. There she is. Here they are, that the people she met with, to like a bunch of astronomers. I will go through the different people she met with. The point to be made is that this is both the she went to the Tycho Brahe's observatory on the island of Ven between Denmark and Sweden. The point to be made, of course, is that these are all men, white men. There's some more of them. And when I was talking about this with Elisa Goodman, who is some ways her successor, she's an astronomer at Harvard. And I was like, do you know who? She's like, oh, these are the who's who of astronomy in that period. And she gave me what they're known for. So that was fun. She was also invited out to the Pulkova University, observatory rather, which is just outside Leningrad in the Soviet Union, by a man named Boris Gerasimovich, its director, who she had met in Cambridge in Massachusetts a few years earlier. And so this was extraordinary. It was the Soviet Union, Stalinist Russia. She went out for 11 days in July of 1933. And she met there with a number of astronomers, including, I love these photographs, these men, whose names aren't relevant here. She got to hold Kepler's notes and manuals in her hands, and she called these relics. Fun for me, because I'm studying relics. But it was an appalling and deeply moving experience for her, which she recorded in this travel diary in my possession. Her observations are so interesting. So you'll remember this is Stalinist Russia. The Soviet Union was in the middle of a great famine at the border. On the train, they examined her lantern slides and they looked inside every single one of the 100 empty envelopes that she was carrying with her. But she was truly appalled at the conditions she witnessed, the poverty, the dirt, and the fact that the buses never came and that they ended up having to walk everywhere without concern. Anyway, from there, collecting her grips about her and quite shaken to the core, she went to Germany, first to Berlin and then to Göttingen, where the international meetings of the Astronomical Society, around which she had planned her trip, were being held that year. And there she met another bunch of important astronomers and reconnected with her hero, Eddington. Now, if you Google Germany 1933, this is what Wikipedia gets you. To say the least, it was a tense time, and for many, terrifying. Adolf Hitler had been appointed chancellor on January 30th, and he declared the Third Reich on March 15th. And at the Astronomical Society meetings in August, she was introduced to a Russian emigre astronomer named Cecilia Gaposchkin, who, incidentally, met my other grandfather in Berlin in these years, laying the seeds for my parents to meet in the 50s. That's fun. All right. Anyway, Sergei was he was Russian. He was from the Crimea. He was living in Germany, unable to get back home. Of course, Russia was going through its own upheavals at the time. And he was considered a white Russian, had fought part of the Tsar's army in the 1920s. At one point, he was detained by the Germans, who suspected him of being a Russian spy. Needless to say, it was not a good time to be a stateless Russian in Germany. And so when Cecilia met him, she was clearly quite moved by it. When she got back to the States, she went into full gear to get Sergei to America. She traveled to Washington to get him papers. She cashed in whatever social capital she had at Harvard to get him work there. He was ultimately named the Harvard astronomer. Nobody knows what that means. He arrived 8 months later, and they were married, to everyone's shock, just a few months after that. It was at this point that she became Payne-Gaposchkin, a quite early foray into hyphenation. Here they are early in their marriage. It's about this time they bought a house out in Lexington, the town I grew up in, the house that I remember from Sunday dinners. They collaborated on work. They had 3 children in fairly quick succession. There's my father, Edward Michael, who looks amazingly like my younger son did at about 11 or 12. It's kind of moving. Then my Aunt Catherine, and then Uncle Peter. Let me just say here what in my academic world is obvious. It's hard to be a working mom. In academia in the 1930s and 40s, it was essentially unheard of. Let's get back to her professional trajectory. From 25 until her death in 1979, she continued on a path of active inquiry and discovery. As I said, she was employed at the Harvard College Observatory in a permanent but not a faculty position. She did some teaching, and she became the editor of the Harvard Astronomical Publications. But she wasn't given a prestigious position, nor one that had any advancement capacities, either professionally or remuneratively. And it grated, and she generally blamed it on living in a man's world. But she was also always so grateful to be able to do the work that she loved, which would not have been possible for her in England. It wasn't until some years later, in 1952, when she was 52 years old, that things were set right. She later described this as the advancement that was finally accorded to me. So this is Donald Menzel, a contemporary from Princeton, one of Russell's students, who had been pitched to her as a kind of rival or competitor because they were working in the same areas. And he was named as director of the observatory when Shapley stepped down. She wanted that position. She believed she was not able, that it wasn't open to her because of her gender. Don't know if that's true or not. In any event, when Menzel arrived, he opened the books and he was shocked to find out how little she was making. And he essentially doubled her salary overnight. In 1954, she was given a proper faculty position at Harvard and then appointed quickly thereafter as full professor. She was the first woman so named in the Faculty of Arts and Sciences in 56. She was made, this is not an honor, chair of the department, but she was the first, obviously, because she was the only woman on the faculty, she was the first female chair of a department at Harvard. And in 58, the trustees, the famous Harvard Corporation, elected her to be the Phillips Professor of Astronomy. It's also at about this time that she was elected to the Royal Astronomical Society and received several other awards, including being the first woman to be awarded something called the Rittenhouse Medal, which is awarded for outstanding achievement in science of astronomy. Now, the appointment to the Harvard faculty was probably the single most obvious moment of professional recognition for her. In the American Academy in 1952, it was still extremely rare. She was not a fussy woman, but it was, I think, of some satisfaction as she grew into her 60s and 70s that she was increasingly appreciated for the pioneering work that she had done throughout her career. Although she is still primarily celebrated for her work from 1925, she in fact continued to do serious research throughout her life. In the quarter century between her dissertation and her appointment to the faculty, she made a series of contributions to the understandings of stellar atmospheres, variable stars, pulsars, and Magellanic clouds. Again, things that mean nothing to me. She also began experimenting in the use of statistical methods in working in astronomy. My dad once told me that near the end of her life, she got very excited about the possibility of computers, of what computing could do for the field of astronomy. Henry Norris Russell ultimately acknowledged her contribution, although, as you heard, the implications of her work are still often credited to him. That said, after her appointment in 1952, and this is a lesson for all of us academics, she had much less time for pure research, and that period of her career was devoted mostly to writing. She wrote to a broad audience, a widely used textbook, Introduction to Astronomy, and this other book, Stars in the Making, that went through several printings. And of course, she had her own students teaching, mentoring, advising doctoral students. And of course, time can mend. Harvard itself has been increasingly embraced Payne-Gaposchkin as part of their faculty. In 2002, a formal portrait of her was commissioned by Harvard from an artist, Patricia Watwood, to be hung in the faculty room at University Hall. Partly, it was joked at the time, it was an affirmative action portrait, because the only other woman commissioned at the same time to have a portrait in the faculty room was a medievalist, actually Helen Maud Cam, who is the other early woman to be appointed to the faculty. So that pleases me again, because that was a medieval historian. I think this portrait is wonderful. The artist said she was inspired by Vermeer's portrait from 1668 of the astronomer. But truth be told, my favorite picture of her is this one, the one we started with, the image of the woman at work doing the thing that sustains her and enlivens her, the woman here, the astronomer, looking into the stars.